Hey guys, just a set of very short notes today. I believe we're in section 4 of your packet. We're going to talk a little bit about nuclear fusion. Alright, another word for it is called nucleosynthesis that we're going to be talking about. And it's how heavier elements in the periodic table are formed. Because so far we've talked about the, uh, the universe only having mostly hydrogen and helium. Alright, so fusion happens on a subatomic level. There's three particles that you should already be aware of, which is protons, neutrons, and electrons. When we talk about fusion, we are mostly talking about protons. Um, what identifies an element is the protons itself. So if you have one proton, it's helium. If you have one proton is hydrogen, two protons is helium, three protons is lithium, four protons is sodium, and so on. What changes the weight of an element is not only knowing the protons, but the amount of neutrons in there as well. So you can get what's called different isotopes when you have different amounts of neutrons in there. Fusion is basically the smashing together of atoms or particles. So it's taking two of those protons, smashing them together. Protons, remember, have a positive charge, and if you've ever tried to stick two magnets together and it repels itself, that's why it has to be the smashing together of atoms, because otherwise they naturally repel away from each other. Under intense heat and pressure, it forces those collisions to combine together, and it actually changes the charge of one of those molecules into a neutral neutron. Um, as far as how much energy does it produce, the energy released from from the fusion of 1 gram, which is very, very tiny, of hydrogen 1 is equal to burning 5,000 gallons of gasoline or over 20 tons of coal. This is also why fusion, learning about this in the 1920s, led to being able to make atomic bombs. Alright, so how does it work? So I mentioned earlier, it's all about the proton. When we have 4 hydrogen nuclei, it's basically a hydrogen atom without its neutron. Right? When 4 of them combine together through the smashing and collision, it forms 1 helium atom. 2 of those nuclei remain protons, and 2 of them become neutrons to help balance it out. And then there's that release of energy. So you can kind of see that going on up in here in this picture right here. So you've got a couple different versions of hydrogen atoms, and then fusion happens, that smashing together, and you come up with helium, another neutron to go running around, and then the energy that's released from it. So when we're talking about 3 helium atoms, so remember helium has 2 protons, 2 neutrons, when those collide together, 3 helium create 1 carbon atom, and that carbon atom has 6 protons and 6 neutrons, and that also releases energy. If you want to think back to your math class, this is almost like boiling. Alright, so we have our 3 helium, and because each of those has 2 protons and 2 neutrons, so 3 times 2 gives us 6. Same for both the neutrons. So if we have 4 helium atoms, that's going to give us 8 protons and 8 neutrons, because 4 times 2 is 8, plus the energy. So that is actually going to give us an atom of oxygen. Now if we have a carbon, which has 6 protons and 6 neutrons, and an oxygen, which is 8 protons and 8 neutrons, we end up with 1 silicon atom. And of course the energy as well. Now how could you make iron? Number 26 on the periodic table. Now you could do this several ways. But, alright, so you could do it a number of ways, but I feel like one of the easiest ways would be 4 carbon atoms. 4 times 4 is 16. A helium, um, 4 times 6 is 24. And then a helium atom, which has 2 protons, 2 neutrons. That will give you your 1 iron. Iron, and we'll talk about later on, and it's been mentioned a little bit already, is what eventually stops the sun from being able to burn its fuel once it releases that energy. But there's definitely more than one way to do it. So in your packet, you will have a video to watch. The link is right up here. It's also in the PowerPoint and a few questions to go along with it.